TryHackMe, HTTP in detail. Learn about how you request content from a web server using the HTTP protocol. Task 1. What is HTTP or ACE? So what is HTTP? Hypertext Text Transfer Protocol. HTTP is what's used whenever you viewed a website. Developed by Tim Berners-Lee and his team between 1989 to 1991. HTTP is the set of rules used for communicating with web servers for the transmitting of web page data, whether that is HTML, images, videos, etc. So what is HTTPS? Hypertext Transfer Protocol Secure. HTTPS is the secure version of HTTP. HTTPS data is encrypted, so it not only stops people from seeing the data you are receiving and sending, but it also gives you assurances that you are talking to the correct web server and not something impersonating it. Yeah, so questions. What does HTTP stand for? Hypertext Transfer Protocol. What is the ACE in HTTPS? Stand for secure. On the mock web page on the right, there is an issue. Once you have found it, click on it. What is the challenge flag? View the website. Welcome to TryHackMe. I think the problem is, can we change? So what can we do? You got a flag just by clicking on the link above. Okay. Alright. Task 2. Requests and responses. When we access a website, your browser will need to make requests to a web server for assets such as HTML, images, and download the responses. Before that, you need to tell the browser specifically how and where to access these resources. This is where URL as URLs will help. Let's close the website so we can see more. What is a URL? Uniform Resource Locator. If you have used the internet, you have used a URL before. A URL is predominantly an instruction on how to access a resource on the internet. The below image shows what a URL looks like with all of its features. It does not use all features in every request. The first one, HTTP, is scheme. Second one is user. Third one is host, or you call it domain as well. Fourth, port. After semicolon. Fifth one, path. Sixth one, query string. Seventh, fragment. So you can see each part we have a symbol before features. Okay. Scheme lists instructs on what protocol to use for accessing the resource, such as HTTP, HTTPS, FTP, which is a file transfer protocol. User. Some services require authentication to login. You can put a username and password into the URL to login. Host. The domain name or IP address of the server you wish to access. Port. The port that you are going to connect to. Usually 80 for HTTP and 444, so 443 for HTTPS. But this can be hosted on any port between 1 to 65,535, or you can just name it 65535. Next one, path. It's path. Yes, path, the file name or location of the resource you are trying to access. Query string. So extra bits of information that can be sent to the requested path. For example, /blog ID equals 1 would tell the blog path that you wish to receive the blog article with the ID of 1. Fragment. This is a reference to a location on the actual page requested. Yes, so this is commonly used for pages with long content and can have a certain part of page directly linked to it. So it is viewable to the user as soon as they access the page. So how can you make a request? It's possible to make a request to a web server with just one line, which is get/http/1.1. So how does it works? Let's have a look. The request method, the HTTP protocol version, the page being requested. So what does that mean? For much richer web experience, you will need to send other data as well. This other data is sent in what is called headers, where headers contain extra information to give the web server you are communicating with. But we will go more into this in the header task. This is the example request. So we give it a request and give the host name, the user agent's information, and the referrer to break down each line of this request. Line 1. This request is sending the get method. More on this in the HTTP methods task. Request the home page with / and telling the web server we are using HTTP protocol version 1.1. Line 2. We tell the web server we want the website TryHackMe.com. We want this one. Host, which is a server. Line 3. We tell the web server we are using Firefox version 87 browser. Line 4. We are telling the web server that the web page that referred us to this one is https://tryhackme.com. Line 5. HTTP requests always end with a blank line to inform the web server that the request has finished. So we want this website, and HTTP ends with a blank line to inform the web server this request is over. Example response. Let's have a look. We are familiar with 5 lines here, but what is this? If you have no idea what's that, you need to understand HTML to break down each line of the response. Line 1. HTTP 1.1 is a version of the HTTP protocol that server is using, and then followed by the HTTP status code, in this case 200 OK, which tells us the request has completed successfully. Nice. Line 2. This tells us the web server, software, and version number. Line 3. The current date, time, and time zone of the web server. Line 4. The content type header tells the client what sort of information is going to be sent, such as HTML, images, videos, PDF, XML. So XML is Extensible Markup Language. Line 5. The content length tells the client how long the response is. This way we can confirm no data is missing. Line 6. HTTP response contains a blank line to confirm the end of the HTTP response. Line 7 to 14. The information that has been requested, in this instance, the home page. So this is the home page. Questions. What HTTP protocol is being used in the above example? So I think it's HTTP 1.1 / 1.1. Correct. What response header tells the browser how much data to expect? How much data? I think it's content length. I think it's content length. What response header? Content length, I think is this one. Correct. We just need to add a dash in between. Task 3. HTTP methods. HTTP methods are a way for the client to show their intended action when making an HTTP request. There are a lot of HTTP methods, but we will cover the most common one. Although mostly you will deal with the GET and POST method. GET request. This is used for getting information from a web server. POST request. This is used for submitting data to the web server and potentially creating new records. PUT request. This is used for submitting data to the web server to update. So which means we have already have a data, at least, in the web server. But compare with POST request, there is no data in the web server. Fourth, delete request. This is used for deleting information or records from a web server. Questions. What method would be used to create a new user account? So, which is POST. What method would be used to update your email address? PUT. What method would be used to remove picture you have uploaded to your account? Delete. What method would be used to view a new article? GET. Correct. Task 4. HTTP status codes. HTTP status codes. In the previous task, you learned that when an HTTP server responds, the first line always contains a status code informing the client of the outcome of their request, and also potentially how to handle it. These status codes can be broken down into 5 different ranges: 100 to 199, which is information response. These are sent to tell the client the first part of their request has been accepted, and they should continue sending the rest of their request. These codes are no longer very common. Next one, 200 to 299 success. This range of status codes is used to tell the client their request was successful. Next one, 300 to 399 redirection. These are used to redirect the client's request to another resource. This can be either to a different web page or a different website altogether. Fourth one, 400 to 499 client errors. Used to inform the client that there was an error with their request. The final one, 500 to 599 servers errors. This is reserved for errors happening on the server side and usually indicate quite a major problem with the server handling the request. So, the error happening on the server side. Common HTTP status codes. There are a lot of different HTTP status codes. That's not including the fact that applications can even define their own. We will go over the most common HTTP responses you are likely to come across. 200 OK, this request was completed successfully. 201 created. A resource has been created. For example, a new user or new blog post. 301 moved permanently. This redirects the client's browser to a new web page, or tells search engines that the page has moved somewhere else and to look there instead. 302 found. Similar to the above permanent redirect, but as the name suggests, this is only a temporary change, and it may change again in the near future. 400 bad request. This tells the browser that something was either wrong or went missing in their request. This could sometimes be used if the web server resource that is being requested expected a certain parameter that the client didn't set. (401) Not authorized. You are not currently allowed to view this resource until you have authorized with the web application, most commonly with a username and password. (403) Forbidden. You do not have permission to view the resource whether you are logged in or not. 405 Method not allowed. The resource does not allow this method request. For example, you send a GET request to the resource or create account when it was expecting a POST request instead. Use the wrong method. So 404, page not found. The page or resource you requested does not exist. 500, internal service error. The server has encountered some kind of error with your request that it doesn't know how to handle properly. 543, service unavailable. So this server cannot handle your request as it's either overloaded or down for maintenance. Click the View Site button on the right to see what some of these HTTP status messages look like in a browser. Forbidden 403. 404, not found. 503, service unavailable. Unavailable. So, questions. What response code might you receive if you have created a new server, a user, or blog post article? So which is 201. 201. What response code might you receive if you have tried to access a page that doesn't exist? Ooh, so I think it's 301. 301. Nope. That is not exist. 44. Correct. What response code might you receive if the web server cannot access its database and the application crashes? Cannot access the database. I think it's internal service error, so it's 500. Nope. You cannot receive because the servers are files free. Correct. Oh, yes. What response code might you receive if you try to edit your profile without logging in first? I think it would be not authorized, so it's 401. 01. Correct. Task 5. Headers are additional bits of data you can send to the web server when making requests. Although no headers are strictly required when making a HTTP request, you will find it difficult to view a website properly. So common request headers. There are headers legs are sent from the client. Usually your browser is the client, to the server. Host. Some web servers host multiple websites, so by providing the host headers, you can tell it which one you require. Otherwise, you will just receive the default website for the server. User agent. This is your browser software and version number. Telling the web server your browser software helps it format the website properly for your browser, and also some elements of HTML, JavaScript, and CSS are only available in certain browsers. Content length. When sending data to a web server such as in a form, the content length tells the web server how much data to expect in the web request. This way, the server can ensure it isn't missing any data. Accept encoding tells the web server what types of compression methods the browser supports, so the data can be made smaller for transmitting over the internet. Cookie. Data sent to the server to help remember your information. See cookies task for more information. Common response headers. These are the headers that are returned to the client from the server after a request. Set cookie. Information to store which gets sent back to the web server on each request. See cookies task for more information. Cache control. How long to store the content of the response in the browser's cache before it requests it again. Content type. This tells the client what types of data is being returned, i.e., HTML, CSS, JavaScript, images, PDF, video, etc. So using the content type header, the browser then knows how to process the data. Content encoding. What method has been used to compress the data to make it smaller when sending it over the internet? So what header tells the web server what browser is being used? I think it's user agent. What header tells the browser what type of data is being returned? Content type. What header tells the web server which website is being requested. Since host. Alright. Task 6. Cookies. So you have probably heard of cookies before. They are just a small piece of data that is stored on your computer. Cookies are saved when you receive a set cookie header from a web server. Then, every further request you make, you will send the cookie data back to the web server. Because HTTP is stateless, which means it doesn't keep track of your previous requests. Cookies can be used to remind the web server who you are, some personal settings for the website, or whether you have been to the website before. Let's take a look at this as an example HTTP request. Ooh, that's quite large. So the client requests the web page from this cookie.thm, this URL. So this is the request is sent. It's going to visit this URL, and this is the browser. The server responds back with a simple web page with a form asking for the user's name, server, date, content type, HTML data. This client sends back the form with the name set to Adam, named equals Adam. The server responds with a set cookie header, telling the client to save the data name equals Adam. On the next and every further request, the client sends the cookie data back to the server. The server then sees the cookie data, and instead of displaying the form, it displays a welcome back message instead, because the web server now remembers you from the cookie. So cookies can be used for many purposes, but are most commonly used for website authentication. Cookies can be used for many purposes, but are mostly commonly used for website authentication. The cookie value won't usually be a clear text string where you can see the password, but a token. unique secret code that isn't easily humanly guessable. So like it's a token secret code. So viewing your cookies, you can easily view what cookies your browser is sending to a website by using the developer tools in your browser. If you are not sure how to get to the developer tools in your browser, click on the View Site button at the top of this task for how-to guide. So here is a guide for you to accessing developer tools. This is for Firefox, Chrome, Safari, Edge, Internet Explorer. Right, that's all. So, questions. Which header is used to save cookies to your computer? Which header? Host or set cookie? I think set cookie. Correct. Task 7. Click the View Site button on the right. This is an emulator for making demo HTTP requests. Using what you have learned from the both tasks, you can use it to complete the below questions. Make a GET request to -room. GET to a room. Go. So we have a flag because now the server returned a HTML. Make a GET request to /blog and using the gear icon set the ID parameter to 1 in the URL field, blog, and use the icon set the ID parameter to 1. Ooh. So let's go. I found an other flag. Make a delete request to user 1. Alright. Ooh, I think our page is a bit cramped. User is deleted. Make a put request to user 2 with the username parameter set to admin. So we set the user 2 username parameter username to admin. Cannot find the page. User 2. Oh, I changed I should change. Nice. Post the username of THM and a password of let me in. So when you log in, we can set a value. The key is password. Let me in. Go. Nope. Login. Post the username. Oh, so it's since user. Oh. Login. Password lets me in. User. Maybe just type the username here. THM. Save. And just login. Great. So we have a flag. Alright. And great. Let's do next room.